In previous sessions we discussed about free body diagram, Newton's second law and its application. Now we are going to discuss about problem-solving approach of laws of motion. You should take the following steps to solve the problems of laws of motion. This one is first step. Read the problem many times until you have a good mental picture of what the situation is. Draw the figure of the situation and try to relate the situation to real world. Write the given data and, most important, what is asked. Now our next step. Draw the free body diagram of the concerned body. If you have any problem regarding the concept of free body diagram, you can once again go through the first session or part 1 of laws of motion. Now there can be a requirement of resolving of forces acting on the body along some suitable axis. But in some situation, you need to resolve the force, and in some situation there is no need to resolve. It depends on the problem and axis that you choose to solve the problem. After the above step, apply Newton's second law in the respective axis. Take this problem. First, read the problem carefully. Here 3 blocks of different masses are connected by light strings. A force of 60 Newton is applied on block of mass 4 kilograms towards right, that you can see. Underline the assumptions in the problem. There are 2 assumptions. One is surface is frictionless, hence frictional force will not be considered. Other assumption is that strings are massless, that means tension will remain same throughout in one particular string, although tensions are different in different strings. Relate this problem to real life situation. What you can do. Take blocks and connect them by strings and pull them. Now our main concern is that what is asked in this problem. Here, in first part, we have to find the acceleration of each block. The acceleration of each block will be the same, but why? Because each block will have same displacement during same time, that you can think very easily. Now you can draw the FBD of all the 3 blocks together because all of them have same acceleration. Think what are the different forces are acting on this system. FBD of system is shown in figure. For this system, there are 3 surroundings: horizontal surface, earth and 60 Newton force. A total of 5 external forces are applied that you can see. The horizontal surface pushes up the block of mass 10 kilograms with normal reaction R1. The horizontal surface pushes up the block of mass 6 kilograms with normal reaction R2. The horizontal surface pushes up the block of mass 4 kilograms with normal reaction R3. An external force of 60 Newton towards right on block of mass 4 kilograms. The earth pulls down the system with force of 200 Newton, the combined weight of the system. Now take x-axis along right and y-axis along vertical direction. To find the acceleration, apply Newton's second law, along x-axis. What is the net force along x-axis? It's 60 Newton, hence this net force equals to the product of total mass and acceleration of the body. From this get the acceleration of the body. Now we discuss the second part of problem. In this part we have to find the contact force between 10 kg block and horizontal surface, which is the pushing force, R1 by surface on the block. After that we have to find the pulling force, tension T in the string connected between the block of mass 10 kg and 6 kg. What will be the approach of the problem? To find R1 and T, we choose 10 kg block as system. Draw FBD of this block and apply Newton's second law. To find T, we can have various approach and we discuss them one by one. Here we can see the FBD of 10 kg block. There are three surroundings for this system. One is Earth, which is applying a downward pulling force of 100 Newton, equals to weight of block. Second surrounding is surface, applying a pushing force R1 on the block. Third surrounding is string, which pulls the block towards right by a force, known as tension T in the string. The acceleration of block is 3 meters per second square along x-axis, that we have calculated in first part. Now apply Newton's second law along x-axis. The only force which is acting along x-axis is T. Hence net force along x-axis is T, which equals to the product of mass of block and acceleration of block along x-axis. From this we get the value of tension in string, which comes out 30 Newton. Now apply Newton's second law along y-axis. The forces which are acting along y-axis are R1 and 100 Newton in opposite direction. Take upward direction as positive. Hence net force along y-axis is R1 minus 100. It equals to the product of mass of block and acceleration of block along y-axis. As acceleration along y-axis is 0, R1 minus 100 equals to 0. From this we get the value of R1, which comes out 100 Newton. This is the approach to find R1 and T. Now we discuss other approach to find tension T. We can find T by some another method. In this approach, we take the system 6 kg block and 4 kg block together. For this system, the surroundings are horizontal surface, applying R2 and R3. Earth, applying weight of 100 Newton vertical downward. String, connecting 10 kg block and 6 kg block, applying pulling force tension T towards left on 6 kg block. External force, 60 Newton, towards right on 4 kg block. Now we draw the FBD of the system, that you can see. Apply Newton's second law along x-axis. The net force along x-axis is 60 minus T, which equals to product of mass of system under consideration and acceleration of system along x-axis. Hence 60 minus T equals to 30, and from this we can calculate the value of T. This one is next approach to find T. In this approach, take 6 kg block as system. For this system, surroundings are horizontal surface, applying normal reaction R2 vertical upward. Earth, applying the weight of block of 60 Newton vertical downward. String, connecting the block 10 kg and 6 kg, pulls the block of mass 6 kg towards left with tension T. String, connecting the block 6 kg and 4 kg, pulls the block of mass 6 kg towards right with tension T1. Now we draw the FBD of block of mass 6 kg, that you can see. Apply Newton's second law along x-axis, and net force on the block along x-axis is T1 minus T, which equals to the product of mass 6 kg and its acceleration 3 meter per second square. Hence T1 minus T is 18. To find T, we have to find T1. To find T1, consider 4 kg block as system, or consider 10 kg and 6 kg blocks together as system. Now to find T1, draw FBD of block of mass 4 kg, which you can see. Apply Newton's second law along x-axis and get the value of T1. The value of T1 is 48 Newton. Now, from T1 minus T equals to 18, get the value of T.